Well, Bismillahirrahmanirrahim. Assalamu alaikum. In this session, we will be discussing what happens if Levene statistic is rejected. What does that mean? When Levene statistic is rejected, when the null hypothesis of Levene test is rejected, it means the variances are unequal. So, well, if there is presence of unequal variances, or when there is heteroscedasticity in the model, then you need to investigate it further whether there is um, a model misspecification. So how do you know it? Whether model is misspecification, how it can be done? We are using the data of credit card from the SPSS file, and we need to estimate, regression, and instead of linear, we estimate curve. Our dependent variable is the total spending, and our independent variable, which means the covariate, the number of items as independent variable. And how many regression you can estimate? There are multiple options: linear, quadratic, and cubic, or some other, for example, power or logistic or exponential, and there are multiple options as well. You can add more options. Well, here for simplicity, we are selecting just 3 options. And you can also label case, for example, if you want to add the categorical variable, you can do it, but we want to keep it very simple, like okay, and the results will guide you. These are the results. So this is the fitting of the regression line: linear, non-linear, quadratic, cubic. All the 3 have been fitted here within the observation, within the number of observations. So how will you compare from the R square value? You can see for the linear, the R square is 75%. For quadratic, it is 78%, and cubic 78%. There's not much difference. So it means we can go ahead with the linear line. But this time, if this is the case, then just go ahead, estimate the model. But this time you need to univariate spending and all these things. But this time you need to save, standardize. Let me show you my notes so that you can remember it. Look, scatter plot we have already done. Now this time you need to estimate the ANCOVA with the interaction effect. This is another option, interaction effect. So how to do it? How to estimate with interactive effect? Model, and in the model, customs, and these 2 we will be estimating their main effects of the 2 independent variables on the dependent variable. One of them is categorical, the other is continuous. Card is categorical, item is continuous, it has values. And main effect mean their independent effect on the dependent variable spending, and then their interaction effect. We want to see whether one of them has moderating effect or not. So if we estimate it like this, and we want to save some of the things, for example, y hat we want to save, and then unstandardized value of mu and standardized value of mu. Even one of them is can also be sufficient. For example, standardize or z value of mu, the z value of mu. We continue, okay, and anything else, whether the options are there correctly selected. And if you want to see the plot, yes, we want to see the plot. It is already here. I think it is already here, so we don't need to, the selection is already made. So we click OK. Now this type of result will now enable us to understand as to the heteroscedasticity, whether we have correctly specified model, because one of the reasons for heteroscedasticity can be model misspecification. Look, the cross product term which we are searching for, the cross product term, which is actually card multiplied by items. So that it actually is the coefficient of it is F value of this is significant, but the effect size is not so significant. It is just 0.4%. Let's see the parameter estimates. The parameter estimates of the cross term, for each item, for each type of card, yes, it is significant. So there is moderating effect of, the card 1 moderates, 2, 3, 4. So there is moderating effect, and this moderating effect is significant, but the effect size is not big, though it is significant. So it means the type of card moderates relationship between the independent variable known as items and the dependent variable spending. So it moderates, the type of card moderates the relationship between covariate and the dependent variable. When I say covariate, it means in independent variable, a continuous nature. So there is significance. So that can be perhaps the reason. Now you can plot and see the graph, legacy plot, and here scatter plot, and this time simple scatter, continue defining. Here we want to reset it. This is the normalized or standardized value of the mu or residual. We use it as a dependent variable, and items, which is covariate, and set marker card. So for each, we want to see what is the nature of relationship, whether it moves around 0 or not. If it is flat, let's see it is flat or not. We insert a line within this, and this line, if it is flat, so these lines are flat. So we apply linear. So linear line is already there. Linear line and apply. And when we apply it, you can see it is almost flat. So I close it. I close it too. See what we need to know. If this line is almost flat, you see it is flat, but the spread is increasing. So there is heteroscedasticity. So it means now we need to treat this model. So that requires a detailed discussion on the removing measures or remedial measures of heteroscedasticity. That is not part of our today's ANCOVA analysis. That is the part of further discussion of advanced topic. So this is how we can say. And another thing, there is another way of plotting the graph. For example, like this. Let's follow our notes. Y hat against IV and IV cat. So how it can be done? We have already saved our predicted value. This is the value Y hat which we saved unstandardized, and then on x-axis this, and set marker by card. And when we see here, we can actually know in detail as to which card is actually causing the heteroscedasticity. The spread actually helps us know whether the heteroscedasticity or variance is due to which type of cards. So if we put here line, and this line is this one. So it may take. So look, this is how you can determine what is the source of heterogeneous variance. Okay, so this is this is all about ANCOVA, or one-way ANCOVA, and there are multiple ANCOVA model. We will be discussing them in detail. Further model will be discussed in the next video. Thank you.